In this week's lab, we're going to be conducting a synthesis of aspirin. So for those of you that have the textbook, I highly recommend you reading it. It's chapter 41, pages 531 to 536. This lab is not in the lab manual that I handed out in the beginning of the lab, so you'll need some kind of reference. This video should be good enough, but you should take a look at the textbook as well. All right, so the overall reaction involves the acylation of the OH group on salicylic acid. So the phenolic OH group gets acylated with acetic anhydride in the presence of phosphoric acid as a catalyst to give acyl salicylic acid, which is aspirin. So we're only doing a single step reaction here. So this is an esterification reaction. Okay, our procedure, we are going to weigh out 138 milligrams. So when you come in, that should be the first thing you do. You're going to weigh it out directly into the test tube. Transferring small amounts of material, we always wind up losing material. If you put it right into the vessel that you're going to do the reaction in, there'll be no loss of that material. All right, so once you have the 138 milligrams weighed out directly into the test tube, you're going to add 1 drop of phosphoric acid to that, as well as adding 0.3 milliliters, which is 12 drops of acetic anhydride. We're then going to warm that up to about 90 degrees. So stick it in some boiling water for about 5 minutes. Okay. When the reaction's complete, after that 5 minutes, we're going to do the quench of this reaction. And this you have to be careful. We're going to take 0.2 or 8 drops of water, 0.2 milliliters, 8 drops of water, and add it dropwise. So we should cool the solution down from the 90 degrees first, and we're going to slowly add that water to it. All right. This is going to get hot. There is excess acetic anhydride, which is this, that's going to react with the water to give 2 equivalents of acetic acid. So this is just the hydrolysis of any excess reagent that we have in here. We have to do it slow, right? After we add that 0.2 milliliters, we're going to follow that up with another 0.3 milliliters of water, and we're going to cool that in the ice bath. At this point, we should be able to collect the solids by filtration. We're going to use all our crystallization techniques. If it doesn't crystallize right away, we're going to filter that solid and air dry it and weigh the solid so we can get our yield for the reaction. Okay. The mechanism of this reaction. So actually the mechanism in your textbook does not show the mechanism acid catalyzed. So I'm going to go through that with you. It's a little involved, and I want to make sure that you understand each step of the mechanism. So I'm going to start as close to the top here as I can. The first part of this reaction is going to be the acetic anhydride is going to react with the phosphoric acid. All right, this is going to be an equilibrium reaction. I'll draw phosphoric acid out. All right, so phosphoric acid looks like this. So one of the lone pairs on this oxygen is going to attack the hydrogen of phosphoric acid. So this is a protonation reaction. And what we're going to get from this is protonated acetic anhydride. All right, so this protonation, what it does is it activates our electrophile. All right, so our electrophile is going to be the protonated acetic anhydride, and the nucleophile is going to be our salicylic acid. So I'll draw that here. And the salicylic acid is going to attack, the OH is going to attack this group here. And The reason that the acid catalyst helps is this is a much better electrophile now that we've activated it by protonated the acetic anhydride. So this attack is easier. So this part of the reaction is the nucleophilic attack. Okay, so nucleophilic attack. And the product of that is going to look like this. I'll draw out the hydrogen a little bit further away from this molecule. Okay, so it's going to look like this and will be protonated on this molecule. All right, so the next part of this is going to be a proton transfer. All right, let's remember that the byproduct of the phosphoric acid reacting is going to be H2PO4 minus 1. Right, that's going to be the anion or the conjugate base of the phosphoric acid reacting. So what happens in this step, we do a proton transfer. It occurs in 2 steps. I'm going to write out the steps individually as to make it as clear as possible what's going on here. So the conjugate base of phosphoric acid is this dihydrogen phosphate ion, and that's going to take that proton from here, neutralizing this molecule. So let's write this out this way. This is the proton transfer. And proton transfer means exactly what you think it means. I'm transferring a proton from one atom to another atom. And this is a stepwise process. Okay, so I've taken off that proton here. I'll redraw this. The methyl group O. Okay, and I've regenerated my phosphoric acid in this reaction. Okay, so that phosphoric acid is going to react again. Now with this oxygen, and again, this is another proton transfer. I'll just abbreviate that as PT. And what I have now is this molecule, and this is positively charged here. And again, I have the H2PO4 minus 1 anion as the byproduct of that. So the reason this happens is I'm activating this group to be a leaving group. So the this piece right here, I'm activating that to become a leaving group by protonating it. So now what happens is the elimination, right? So the lone pair comes in, forms the double bond there, and kicks out my activated leaving group. And the product of that is going to look like this. So this will get the plus charge, and my leaving group is going to be the acetic acid from this reaction. Okay, so I still have my phosphate ion here, so that's going to attack. We're going to do another proton transfer here. And what's going to happen is we're going to generate our acetyl salicylic acid, and I actually forgot some CO2H's here. Let me just put those in. Okay, so that generates our product, and we regenerate our catalyst, H3 PO4. So let's go through this one more time, start to finish, just so we know every step of this reaction. So the acetic anhydride gets protonated. That activates it to be a better electrophile, so a better acylating agent. Our nucleophile, the salicylic acid, attacks our electrophile. So this is the nucleophile. This is the electrophile. It gets attacked. That breaks the double bond and forms the bond between the phenolic oxygen and that carbon. Now we have to do a proton transfer. I need to take this proton off, and I could do that with the dihydrogen phosphate ion and transfer the proton to that to make our phosphoric acid again. And then this lone pair is going to come in and pick up that proton. The reason it does this is I've activated this now to become a better leaving group. The lone pair comes in, forms the double bond, kicking out my good leaving group now. I make acetic acid as the byproduct. And I have this protonated form of acetylsalicylic acid, and my dihydrogen phosphate ion comes in and takes that proton off. I missed the second arrow here. Let me draw that in for completion. Right, so that puts the neutral charge back on that oxygen. I generate my product, the acyl salicylic acid, and I regenerate my catalyst, the phosphoric acid, in this reaction. Okay, so next week, again, this lab is not in your lab manual. We're going to do the TLC lab of the analgesic. So we're going to actually include our sample of aspirin that we make in this, and I'll do another video for that lab for next week.